Good afternoon, everyone, and welcome to today's webinar, Unlock the Power of LoRaWAN for IoT Applications, an in-depth overview. It's a pleasure to have all here today, and I would like to introduce our speakers today. My name is Ilenia Carola. I'm in charge of the business development and at MoveX and our IoT division. And joining us is our electronical design engineer, Alessio Moro.
Hello.
Will help. Ciao, Ale. Alessio will help break down in the technical aspects. So the agenda today, our agendas today is straightforward. In fact, we will be speaking about MoveX LoRaWAN technologies. We will introduce our LoRaWAN module and our Cicerone board. After, we will be speaking about LoRaWAN. For example, do you know the difference between LoRaWAN and LoRa? Do you know the difference between LoRaWAN and the other wireless technologies? If not, you will after this webinar. Then we will be speaking about designing with us, what does it mean, and we will explain how our product helps you to overcome the cost challenges and also to speed up your IoT process. Overcoming the cost and also reducing the time to market. Then we will be focusing on some success stories, and we will be sharing also some real-life LoRaWAN success stories. So if you have any question during the presentation, feel free to type them in the box below, and we will address them in the Q&A session in the end of the webinar. So let's dive in with our first product, and I will pass the mic to Alessio. Hi, Alessio.
Hi. Hello, everyone. Thank you, Ilenia. Okay, I hope you can see my screen. Okay, so let's talk about the MUM WLE module from MoveX. This is a radio module which embeds a LoRa radio and a microcontroller for developing application in the IoT field. For example, for building sensor radars connected to the IoT network and to the internet for building networks of sensor and devices. The MUM WLE module is built around the STM32WLE microcontroller from ST Microelectronics. This is a system on chip which is based on ARM Cortex-M4 CPU core running up to 48 MHz for CPU clock, and it also embeds RAM and flash memory for the firmware uploading. The module has a rich set of peripherals on board, which range from digital interface, analog channels, both input and output, a large number of GPIOs, and all the digital connections such as I2C, UART, and SPI, and so on. The module is optimized for size. As you can see, the size is very small, especially if we compare the size of the product to its capabilities, especially in terms of connectivity, because not only there's a large set of peripherals on board, but it also has a rich pinout, which is the designer of the application PCB, the option to have a flexible mapping of the internal peripherals to the other components of on the PCB board. And also the rich number of GPIOs allows for controlling a large number of external peripherals. So this model is capable of being both the radio provider for the application board, but also as it can be used as the main application microcontroller for the product, because it can run complex firmware, can embed also their LoRaWAN connectivity, and it can connect to a large number of external peripherals. Given the presence of the STM32 family in this model, it's possible to leverage all the STM32Cube ecosystem of software tool. Especially, we have the MX code generator, which is helpful for configuring the peripherals of the device from using a graphical user interface, and then to automatically generate the code for the firmware, where the user then can include its application code and includes all its library for external peripheral. This is done in the IDE software from ST. In case of for users that needs faster and easier programming approach, the model can be programmed using the Arduino IDE thanks to the support package that MoveX provides on its GitHub page, which is free for consultation and for download. Okay, so the MAM-WLE is not a model, but is a family of products. We have 4 different variations of the product, which differed for 2 aspects. First one is the memory size. The module starts from 48K of RAM and 128K of flash memory for the storage of the firmware binary, but can be upgraded to 64K of RAM and 256K of flash in case, for example, of complex and large firmware projects that needs, for example, large libraries and so on. So aside from memory, other variation of the products regards the RF output. There is a version that has an embedded microFI connector, which is useful in case the user don't want to route the RF signal through the application PCB. So the user can develop an easier PCB and without worrying for routing the RF signal. In case, aside from this, in case the user needs, for example, to use another kind of connector, there's the option to use the variation which has the RF output. Has the RF output on a pin of the pinout of the module. This way, the user can choose an external connector, for example, SMA connector, or can use a PCB track antenna, let's say, if this is the case for the application. So this is about the main features of the MAM-WLE module. Let's talk now about another product, which is the Cicerone board. This board is based on the Arduino NKI form factor and embeds the LoRaWAN and GNSS technology in a single package, together with the possibility to operate on battery power. Okay, so why we want to integrate LoRaWAN and GNSS? Yeah, because, for example, it is the main target of many tracking applications. In this case, what we have is an embedded GNSS module that is used for acquiring the position through satellites, and then sending the data collected to a server, where, for example, the fleet management of a large set of devices can be done, and for example, tracking objects, logistics, and so on. The integration between LoRaWAN and GNSS board is very tight because the usage of uBlocks module allows to use the Cloud Locate service. This is a service that makes possible to minimize the power consumption of the board, so to extend the battery life of the device, even in case of GNSS positioning, which, as you know, typically requires a large amount of power. How is it possible? Basically, what the model does, it just collects a snapshot of the signals from the satellites, and instead of doing the decoding on board, it offloads the decoding to a remote server. How is it reached the remote server? It is done through LoRaWAN. That is also a technology that minimizes battery power usage, so it is a perfect match for uBlocks Cloud Locate. As you can see, the board is based on the MAM-WLE module and the MaxM10S GNSS from uBlocks, and in a very small form factor that is compatible, as we saw, with MKR Arduino boards. Through this pinout, it is possible not only to have a small board, but also to expand it through the expansion boards. For example, we can add different kind of sensor, such as temperature, humidity, and so on, to not only target classical tracking application, but also environmental sensing and a huge number of other kind of application based on the expansion board that we choose to install on the board. Also, the board also embeds battery management system, so it is possible to operate it on battery powered by just connecting a LiPo cell to the specific connector. So the board is also optimized for reducing battery and power consumption while having the highest possible battery life, which is a perfect match for all the IoT and tracking applications. Okay, so this is all about the Cicerone and the board and the Mount.ly module. I will leave the stage to Ilenia to go on with other topics. Thank you for now.
Thank you so much. Thank you so much. Can you see my screen? Yeah. Okay, perfect. So thank you so much, Ale. So why LoRaWAN? Why are an increasing number of companies choosing LoRaWAN to enable sensor communication? LoRaWAN is an ideal choice for IoT for several key reasons, such as long range. It covers vast distances. Some applications reach up to 10 kilometers. Also, it's low power. In fact, it's energy efficient. In some cases, even 5 years. One device can reach 5 years of operating without the needs of changing the batteries. Then it has also a high network capacity. In fact, its network can handle many devices in the same place. Also, it's an open standard, really secure, and also it enables also an easy installation, being wireless. That means that all the LoRaWAN devices are user-friendly and plug and play. Also, it's cost-effective, it's budget-friendly. You don't need, in fact, any subscription, as in other technologies. And also, LoRaWAN is a growing ecosystem. More and more companies choose to deploy this wireless communication. So, LoRaWAN's unique features and adaptabilities are playing a revolutionary role in reshaping numerous industries. And let's see how. For example, here we have smart cities, agriculture and livestock, and environmental. Let's speak about smart cities. In the past, city services were manual and imprecise. Now, LoRaWAN enables smart parking, efficient waste management, and more, connecting entire cities on a single LoRaWAN network. Also, agriculture and livestock. Previously, farming relied on manual labor and hazard. Today, LoRaWAN offers precise agriculture with remote monitoring, allowing the farmers to take informed decisions. Then, environmental monitoring. In the past, gathering environmental data was slow and difficult. Now, LoRaWAN enables real-time data collection. In fact, the environmental is one of the biggest LoRaWAN applications. Then going on, we have logistics and supply chain in industrial IoT and healthcare. Logistic. In the past, tracking goods were challenging, and with LoRa, asset tracking and supply chain has been improved. Also, speaking about industrial IoT, LoRaWAN allows efficiency and predictive maintenance. And then speaking about healthcare, LoRaWAN enables remote patient monitoring. That's also another big application. Then we have also retail, utilities, and other modes. In fact, with LoRa, inventory management and customer experience has been improved. And also, LoRaWAN enables a lot of smart grids all over the world and smart metering and management of them. LoRaWAN is transforming all these sectors and making them more efficient and better in general. So Alessio will go on with some difference between LoRa and other technologies, and also how I was saying the difference between LoRa and LoRaWAN
Okay,
when you want.
here we are. So let's talk about what is LoRaWAN and what is LoRa. This is a typical question for newcomers to the technology. Let's start from LoRa. LoRa is a radio modulation developed by Semtech, which is a technology that wants to optimize the battery power, the power consumption for, especially for battery operated devices. It also wants to maximize the working range of devices. So this means to maximize the distance between the transmitter and the receiver of the communication, and while having the possibility to send an amount of data which is typical for sensor application. The LoRa works in the ISM band, so it doesn't require a license to operate, and its frequency can be chosen based on the different region of the world where it is operating. So on top of LoRa, which is the physical layer of the stack, we have the MAC layer, which is called LoRaWAN. And what it does, it is the layer that makes possible to all the devices to cooperate and share the radio channel effectively without collision of packets, without having some devices that take up all the throughput of the network, and so on. The LoRaWAN is developed by the LoRa Alliance, and which is in charge of releasing the official documentation that describe how the network shall be used by the devices and all the operators. LoRaWAN for the focusing on the end nodes of the network. LoRaWAN provides different class of operation for the devices, which are class B, class A, and class C. We start from class A. This targets application where maximum battery power must be achieved. So what it does, it maximizes the battery life, minimizes power consumption at the expense of latency in the receiving of the messages. On the other side, we have class C, which does the opposite. So it doesn't focus on reducing the power consumption, but instead it focuses on reducing as much as possible the latency of the communication. In the middle of them, we have the class B, which does a compromise between the two. So it has good power consumption while having a good latency between the two other classes. Okay, so now we can move on to the next slide. Here we can compare different kinds of technologies. So we can compare LoRaWAN and LoRa to other radio protocols and radio modulations. As we can see, we have three major areas of technologies that differentiate between them based on the coverage range and the bandwidth and battery powered usage. LoRaWAN is in the middle of both aspects of the technology. So it allows to reach large range. So it is possible to have devices spread across a large area. And this means also that if only a few receivers are needed in order to provide connectivity to the installed device. So it is possible also to have large set of devices and a small count of receivers, which for LoRaWAN are called gateways. LoRaWAN also has a, let's say, medium bandwidth for applications such as sensing, because in this application, typically, we don't need to send large amount of data. We just need to, let's imagine, for example, temperature sensing or vibration sensing. What we typically need is to send payloads that are in range of tens of bytes, for example. For this kind of application, LoRaWAN is a perfect fit because accommodate the size of payload that need to be transmitted. It doesn't require to buy a license to operate on licensed bands, such as is the case, for example, for LTE, and 5G. But compared to other technologies such as Wi-Fi and Bluetooth, which also operate in ISM band, it also minimizes the battery power because, there are variations of Bluetooth that allow for low power usage, but in that case, the coverage of the area is limited to tens of meters. With LoRaWAN, we can reach up to 10 kilometers in typical rural scenarios. And this allows to have a range that can cover many applications such as explained by Elenia, from the smart city, smart agriculture, industrial, tracking, and so on. Okay, so this is about LoRaWAN. I will give the stage back to Elenia. Thank you for now.
Okay, thank you, Ale. So, Alessio explained why choosing LoRaWAN is a smart move. Now let's dive into why design with the MAM-WLE from MoveX it's a smart move too. Apart from the hardware, two significant reasons stand out. One is overcoming cost challenges, and the second one is reducing time to market. Let's talk about overcoming cost challenges. First of all, BOM optimization. At MoveX, we have integrated an onboard microcontroller into our LoRaWAN module. What does this mean for your bill of material? That you don't need a separate microcontroller in your BOM. And the beauty of the integration is that you no longer need to include separate microcontroller in your BOM. That means that you have a significant cost saving without sacrificing any functionality. The result is that you achieve significant cost saving without sacrificing anything, and it's a win-win situation for your IoT project. Also, our MoveX module is pre-certified with the CE, the FCC, and the SE standards. So you can avoid costly and time-consuming certification processes for your final product. So what does this mean for you? That you can avoid the often costly and time-consuming certification process, and also that you reduce expenses and provide a competitive advantages. Then let's now dive into another key advantages of designing with the MAM-WLE ready-made RF design. Our MAM-WLE module comes with a pre-certified RF circuit. You don't need costly external testing and tuning, and this means you can bypass the need of costly external testing, and also you can save cost and ensure a wireless communication that is reliable. Also, you can leverage the ST ecosystem, as Alessio was saying. The MAM-WLE is built upon the STM32 microcontrollers, which means that this is a significant advantage because the ecosystem provides a range of development tools, libraries, and resources that are available at no additional cost. Then we have discussed how the LoRaWAN module, our LoRaWAN module, allows you to save money, but it doesn't stop there. It also enables significant time saving. First of all, as we said, certification, a comprehensive documentation, and the use of the ST ecosystem and the attempt support allows you to accelerate the development. Also, our module abstract complex RF design and LoRaWAN protocol implementation reduce the development effort and complexity. This translates in a faster project timelines. This means that you can move forward smoothly and without useless complication. MoveX offers valuable firmware and software support for their modules. So MoveX provides a tailor-made firmware and software libraries specifically designed for the module. And these resources, such as the software and the firmware, reduce the time that you have to use for coding and for debug. Also, as we were saying, the MoveX modules already come with a certification, such as the CE and the FCC. This means that you don't have to go through long and costly certification processes. And in practical terms, it translates in a significant time and cost saving. Then technical support. This is an important one for us. In fact, one of the MoveAxis's key strengths lies in our commitment to an excellent technical support. Provide dedicated technical support to assist the developers in overcoming all the challenges and ensuring a smoother development process. Ultimately, this contributes to a shorter time to market. And in essence, our robust technical support helps you to bring your project to the market really fast. This translates, of course, in marketing opportunity. By speeding up the development process, the companies can promptly enter in the market and be really competitive. Now, let's explore some success stories from our clients who implemented in real life the MAMWLE. First of all, we have Geoandes. This is a system that monitors landslides in real life, thanks to tier of sensors and long range and low power communications. Can also scan the code for more information. There is an article with more information about the application. Then we have Moose Solutions with a smart structural monitoring system. Moose Solutions is our sister company and also is using our MAMWLE. And the system that they are designing ensure infrastructure safety, provide remote monitoring 24/7 in real time, and also has a long-lasting battery life. Also, here you have the QR code to read more about the application. You will also find all this article on our website. Then we have Verfacil. Verfacil, it's in this project cover a wide range of applications, including pump controllers, underground plant rooms, air handling units, IoT retrofilters, and also application in mining vehicles. Also the QR code to read more about the application. Then we have Axtrid with a build health monitoring solution using LoRaWAN, using our MAMWLE. It covers fire detection, air quality, water leak detection in parking areas. And this wireless system offers over 3 years of battery life and provides remote alert to manager for potential issues. The QR code to read more about this application. And last but not least, here there are our contacts from me, Ilenia Carola at movex.it. And then we have also alessio.moro at movex.it. Also, other useful information, it's our website, movex.it. Also, for general information, you can type to info@movex.it. And one of the most useful links are is our GitHub page, github.com/movex, where you can find all the libraries and application notes that we were speaking. Then you can follow us on Instagram and LinkedIn. And also you will find this recording on our YouTube channel shortly and on our website also. Here is a list of our distributors. You can find the Cicerone board on Arduino, and the module and the Cicerone board on DigiKey and Mouser online in their store. And also we have 3 local distributors, such as Schurter for the Italian region. Then we have More Electronics in the Nordics and Sackwell in the Iberic Peninsula. So let's see some question. I know that there are a few of them. Okay, so we have how is your solution compared to the ASP32 with LoRa radio? So Luis, thank you for the question. Actually, we are not allowed to share cross-reference with other competitors. But if you want, you can type to the contact that I was listing, and we will provide you all our documentation so you can compare the two solutions by yourself. Then we have another anonymous one. Who own LoRa base station? Are they already there? I think it means gateways. Right?
Yeah, I think so. I think it refers to gateways.
Yeah.
Gateways are the name of devices that are in the center of the network and that collects the data from the sensor displayed in the application area. There are 2 options for this because LoRaWAN can be used for building both a private network or a public network. Private network is usually owned by the provider of the sensor that sells a complete solutions that as a package that provides both the gateways for coverage and the sensor for the installation in the environment. The advantage of this is that the network can be managed by the specific application, so it can be optimized in terms of efficiency and performance for the specific applications. And also in terms of data security, it also allows for the data to stay inside of a known path owned by the service provider. On the contrary, we have public networks that usually requires to subscribe a service from a provider. For example, TTN is a provider of this kind of service. What this means is that the provider installs the gateway across an area, then the devices can be installed without the need to provide also the gateways. This way, of course, the sensor can be solved without providing also a gateway, but of course you have less chance to control the network, to optimize the network for the application. So both approaches has its pros and cons based on what application you are developing and also on the business strategy of the company. So the choosing one or another is based on the specific case of the customers.
Okay, thank you, Alessio. I hope this is clear, but if you have other questions, you can also type in the contact that we said. Ale, we have our last question is from Ratislav. He asks, is the pre-certification the same for a module with a connector and without a connector? And then he say, I propose a PCB with an NN0222 for antenna. The question is about the pre-certification with or without the connector.
Yeah, for the certification, what is needed is the module is certified with using a reference antenna. What the user can do is to use the same kind of antenna. This also is complex because it varies based on the specific certification we are referring, because of course it's different if we compare the CE for Europe with the FCC for USA. In general, if you use the same kind of antenna as the one used for certification. The model can be found in the datasheet of the module for reference to what kind of antenna it is. Basically, it is a dipole antenna with 2 dB of gain. If you use the same kind of antenna, many cases you don't need to do complex certification test. Also, if you use the RF output through the to the pad, of course, you don't need to redo all the certification, but you only need to do the variation test because we are leveraging the test already done for the model itself. So in both cases, the pre-certification is useful for easing the certification steps.
Okay, so we have an answer from Anonymous that is asking, is the same as before, as the one from the question for the gateways. So he's asking, so I have to build my own network for my sensors or buy a subscription from network provider. How this is better from Sigfox?
Because Sigfox network is owned by a company. So if the company goes down, you can't do nothing. And also, what happens is that your area of operation is not covered by the network. You have the option with LoRaWAN to install your own networks to add coverage to the specific area.
Exactly.
Also, there are other kind of differences between the two technologies, but I think would require some time to answer. Also, LoRaWAN has more flexibility for configuration and also has other features that are not available in other kind of technologies.
Yeah.
If other infos are needed, we can answer through email for you.
Of course. So I will say that that is our last question. So last thing to say is thank you to all the ones that have joined us today, and thank you also Ale for answering the question and for cover all the technical aspects.
Thank you.
Thank you,
Elena.
Bye bye.
Thank you, everyone. Bye.